Okay, so I want to show you guys how to graph an equation such as this that has multiple absolute values. It turns out that when you do this, you have to be very careful. Anytime you graph something that has absolute value, you have to figure out where the boundaries occur. And so the boundary points, or the vertex points, occur where the value inside the absolute value goes from negative to positive. So the way we figure that out is we solve it. So this first equation is true when x is -1. The second equation is true when x equals 1. So that's where the boundary points are. So here's how I'm going to take advantage. Here's how I'm going to use this boundary idea. So here's -1 on the number line, and here's 1. So for this first absolute value, if x is less than -1, then that quantity is going to be negative, and the absolute value switches the sign of negative numbers. So I put a negative in here just to make that point. If x is greater than -1, then, so for example, if x is 4 or -0.5 or 100, then this is a positive quantity. And so if you give an absolute value a positive quantity, it doesn't do anything to it. It leaves it alone. So I'm just going to represent that by just putting a plus. So for the 2x minus 2, again, same idea. If x is greater than 1, then 2x minus 2 is positive and it doesn't do anything. But if it's less than 1, which it is if x is less than 1, or if x, of course, is less than -1, then it's going to switch it. All right, so here's how I'm going to use this information. So to the left, so again, talking about the x plus 1, if x is less than -1, this is a negative quantity, and so the absolute value is going to switch the sign. So x plus -1 is going to become -x minus 1. In this positive zone, it's not going to do anything to it. It's going to stay x plus 1, and over here, it's going to stay x plus 1. Okay, now for the 2x minus 2, same idea. In the far left zone, it's going to become -2x plus 2. I just switched the sign. In this middle zone, it's also going to be -2x plus 2. And in the positive zone, it's going to just leave it alone. So it's going to stay 2x minus 2. Okay, so there's 3 regions here. There's going to be a left region. There's going to be a middle region, and there's going to be a right region. So the left region is just the sum of these two guys. So -x and -2x, that's -3x. -1 and +2 is just +1. In the middle region, x plus -2x is -x. 1 plus 2 is 3. And in the far right region, x plus 2x is 3x. 1 plus -2 is -1. Okay, so these are the guys that need to be graphed now, and that's what we'll do now. So let me write this in a more conventional way. So the top, the -3x plus 1, that's valid when x is less than -1. The middle region is -x plus 3, and that's valid when x is between 1 and -1. And 3x minus 1, that's going to be the right region, and that's valid when x is greater than 1. Now, because we're talking about absolute values, it's going to be the case that these are continuous functions, so it doesn't really matter who owns the boundary. So I'm just going to arbitrarily say this one and this one. It doesn't really matter at all, though. So let's 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay, so let's graph this. So again, we have the left region, which is -3x plus 1. So I need to plug a point in, and that point has to at least include the boundary. So when I plug -1 in, I get -3 times -1 plus 1. So that's going to be, oops, I don't know why it's doing that. Let's see if I can make that go away. Huh, it doesn't want to go away. Let's see here. Maybe that'll make it go away. That's interesting. Okay. Well, in any event, let's just ignore that. Okay. Interesting feature. Okay. So I have -3 times -1 plus 1. So -3 times -1 is 3. 3 plus 1 is 4. So when x is -1, I get 4 1, 2, 3, 4. So it's about right there. Oh, by the way, my boundaries are x equals -1 and x equals 1. Those are my boundaries. Now to get my other point, I know my slope is -3, so I can go up 3, 1, 2, 3, and over 1. So something like this. So it's that. Okay. In my middle zone, oops, I get -x plus 3. So in that zone, I have two boundaries. I have -1 and 1. So when I plug -1 to that, I get the negative of -1 plus 3. So that's 1 plus 3, so which is 4. And if I plug 1 into that, so the negative of 1 plus 3 is 2. So it looks something like this. Okay. And then finally, the right region. So the right region is 3x minus 1, and in that zone, I of course have the boundary of 1. So when x is 1, so 3 times 1 minus 1, 3 minus 1 is 2. And then to get my next point, I can just go up 3 over 1. I know the slope is 3, so I can go up 1, 2, 3 over 1. So it's something like that. Okay, so that's a very rough, very crude example, but that's what it is. So hopefully that helps.